Hi everyone, we will continue to solve amplifier questions. Let's look at the question. Beta is given as, remember beta is Kn, Un Cox, W over L given as 1 milliampere per volt square, and absolute value of V threshold is 1 volt. Here in the question there is one PMOS and one NMOS transistor, and in section A we output equals 0 volts. Okay, let's write 0 volt here. Is required when we input is 0 volts in this operating point. Find ID question 1, ID question 2 and R. Okay, question point, I mean this point means DC bias point. DC bias point, okay, and R, okay. We know in the first question, we know what is V source D. It is 4 volts. Here, it is 4 volts. So we can write the necessary ID equation 1 over 2 Kn, which is 1 milliampere per volt square, V source D, which is 4 volt, minus absolute value of V threshold, which is 1 square, and it is equals to 4.5 milliampere in the first question. Okay, in the second question, I mean it's so easy. Look at here. There is 4 volt voltage drop here, and this is 4K, so there will be 1 milliampere flowing through here. So flowing through here. So ID2 here, this is ID1, is 1 milliampere. This is ID1. So what is left is the R. Okay, let's find R. If 4.5 milliampere flows through here and 1 milliampere flows through here, 5.5 milliampere flows through here. Okay. And also, if I know there is 1 milliampere here for the second transistor, I can write ID equation. It is 1 over 2, and I'm trying to find V source resistor here. It is 1 over 2 Un Cox W over L, which is Kn, given as 1 milliampere per volt square. I mean Vg, it is minus 1 volt minus V source minus V threshold square. So if I do necessary cancellation, 2 becomes minus V source minus 2 square. So square root of 2 equals 1.41. I mean 1.41. V source will be negative and greater than minus 1. I think it's like this. Two plus V source. Why I did? Because inside is negative. This will be negative of the, I mean, I will again write it. Here inside is negative. I am trying to make it positive. How can I make it positive? Simply by multiplying with negative term. It is 2 plus V source square equals 2. So 1.41 equals 2 V source, and V source here becomes 0 minus 0.59 volt. The other term is 1.41 equals minus V source minus 2. Here V source becomes minus 3.41 volts. Which one is correct? So let's think. If V gate is 1 volt, V source is minus 0.59 volt, then VGS is less than V threshold here. So this is not correct. V source equals minus 3.41 volt. If I know V source here and this is minus 4 volts, I can find R because I know there is 5.5 milliampere here. So minus 3.41 minus 4 volts divided by 5.5 milliampere will give me the R value. And R is something like 107.2727. This was the R value. Let's make the section B. Section B asked me the AC gain of the circuits. So how can I find the AC gain? Let's draw the AC equivalent of this circuit first. I will copy it and paste it here. Section B. I will now write the AC equivalent of this circuit. In AC case, remember, DC voltage supplies will be grounded. Also, here, this is grounded. This VGG is also grounded. So, first gain equals, remember, the first gain, there is common source formula. What was common source formula? Remember, it was minus GM RC over 1 plus GM array, or you can say R source and R drain here. So in this question, since R source is grounded, look at this path, R source is grounded, this term cancels and gain is minus GM1 times R source 1. The first part of the gain, if you say here, this is VO1. So VO1 over VI equals minus GM1, and GM1 was equals, we should calculate it. So before doing this, we should calculate GM1 and GM2 values. So GM1 value equals 2 times beta is 1 milliampere per volt square times 4.5 times 10 to 2 minus 3 milliampere per volt square, and this makes 3 millisiemens. And GM2 value equals 2 times beta times, Kn times ID, which is ID is 1 milliampere, 1.41 millisiemens is GM2. So first gain equals VO1 over VI minus GM1 minus 3 times RC1. What is RC1? There is 170 ohm here goes ground, and there is second what I see at the source of second MOSFET. What is this resistance? 1 over GM2. So it is 1 over GM2 parallel 107 ohm. Let's calculate this value. It is 0.278. Okay, let's find the second gain. Second gain is VO over VO1. If I look at the circuit, what is second gain? Right now, I am here. This is VO1. I mean, for second gain, the circuit is like this. Here, my RD goes ground. Here, this is VO1. Here, gate is grounded. What is my RD? 4K. And this is what? This is common base or common gate. I mean, in MOSFET case, common gate gain formula. What was common gate gain formula? It was 9 plus GM times RD in MOSFET case. So V output over VO1 equals GM, which is 1.41 times RD, 4K. And it is 5.64. So my total gain equals V output over VI equals V output 1 over VI times V output over V output 1. And it is 0.278 times 5.64. It is 1.57. That's it, guys. This was section B of the question. Section B of the question. Thank you for listening. See you at the next videos. Take care of yourself.